High tension separation. In mineral processing, electrostatic separation, the electrostatic method separates particles of different electrical charges and, when possible, of different sizes. When particles of different polarity are brought into an electrical field, they follow different motion trajectories and can be caught separately. It is used for separating monazite, spinel, selimanite, tourmaline, garnet, zircon, rutile, and limonite for heavy beach stream placer sand. The electrostatic technique with local modification is extensively used in Australia, Indonesia, Malaysia, and India bordering Indian Ocean for separation of mineral sands. Principles of electrostatic separation. Every mineral species has electrostatic properties that can potentially allow separation in an external electrostatic field. Mineral processing categorizes minerals into conductors and non-conductors, dielectric materials. Which an electrostatic field is applied, they behave differently, thus enabling a separation. Conductor minerals, most sulfides, will lose the charge to an earthen surface, whilst non-conductor will retain the charge and be pinned to the earthen surface. This effect is known as image charge and is the operating principle of electrostatic separator. Its applications. Electrostatic separation enables the separation of a wide range of minerals, and this example, separating pyrite from silica sand, provides a good example of separation process. Principles of electrostatic separation. As we can see, a feed of conducting pyrite and non-conducting silica sand powders is fed via vibratory feeder into an earth, stainless steel rule revolving at a predetermined rate. A strategically positioned electrode assembly at around 20 inches from the vertical charges the feed at high voltage. As the mineral particles leave the vibratory feeder and land on the rule, two behaviors are observed. Conductors, pyrite, lose their charge and are thrown by centrifugal force off the rule. Non-conductors, silica sand, have an image change and are pinned on the rule and discharged by a brush. Minerals separated using electrostatics. The list of minerals classed as conductive and non-conductive minerals is extensive. Such mineral mixes are ideally suited for separation using the electrostatic separator. The following list is not comprehensive but is provided as a guide. Conductors: chalcopyrite, galena, graphite, ilmenite, pyrite, estannite, wolframite. Non-conductors: quartz, feldspar, zircon, apatite, garnet, most silicates, and carbonates. Equipments: roll-type corona electrostatic separator are the most used for the selective sorting of granular mixtures containing plastic and metal particles. Belt-type separator. In a horizontal belt-type separator, fast-moving belts travel in opposite directions adjacent to suitably placed plate electrodes of the opposite polarity. Material is fed into a narrow gap between two parallel electrodes. The particles are swept upward by a moving open mesh belt and conveyed in opposite directions, thus facilitating the particles charging by contact with other particles. The electric field attracts particles up or down depending on their charge. The moving belts transport the particles adjacent to each electrode towards opposite ends of the separator. Plate-type electrostatic separator is used when sorting mixtures of metal particles like aluminum or copper particles. Tube-type separator. In a tube-type separator, the precharging zone and the separation zone are integral parts of the machine. The precharging zone or triboelectrification process exploits the difference in the electronic appearance of the particles involved. The particles become charged by particle-particle contact, particle-wall contact, or both. Particle-particle contact between two dissimilar particles result in the transfer electrons charges from the surface of one particle to the surface of the other. After this transfer, one of the particles is positively charged and the other is negatively charged. And that's all for my report.